Welcome to Why Math Works. Today, the paradox of benches. Welcome to my channel. This is my first video dedicated to the popularization of mathematics. Today, I will present an interesting paradox in probability calculations known in the literature as the bench paradox. Let us say there are 3 double benches in the room. 2 people enter the room and randomly sit down in any of the 6 seats. Let us calculate the probability that both of them will sit on the same bench. Now I provide solution to this problem. Why this problem is called a paradox will become clear shortly. Let us reason as follows. At first, let's denote this event by the letter A. The first person entering the room may sit on any of the 3 benches, so they have 3 choices. The same can be said about the second person, they too may choose any of the 3 benches. If we consider these 9 outcomes equally likely, and 3 of them favorable to event A, then according to the classical definition of probability, we would obtain probability of A which equals 3/9 or 1/3. We may also reason differently. The first person entering the room may sit in any of the 6 seats, and the second person may sit in any of the remaining 5 seats. Thus, the set of possible outcomes, seat occupancy arrangements, consists of 6 times 5 equals 30 equally likely outcomes. Of these, 6 outcomes are favorable to event A, because the 2 people may sit on the first bench in 2 ways. On the second bench as well, in 2 ways. And on the third bench as well, in 2 ways. Therefore, the probability of event A equals 6/30 or 1/5. Which answer is correct? After all, it should not depend on the method of reasoning. The first line of reasoning deserves criticism. The selected outcomes are not actually equally likely, and therefore the answer is incorrect. For example, the outcome in which both the first and the second person sit on the first bench, and the outcome in which the first person sits on the first bench while the second sits on the second bench are not equally likely. In the second method of reasoning, all outcomes are equally likely. Therefore, the essence of the paradox lies in the incorrect application of the classical definition of probability. This problem can also be solved using the law of total probability. Let H1 denote the event that the first person sits on the first bench, H2 the event that the first person sits on the second bench, and H3 the event that the first person sits on the third bench. These events form a complete group of events. The probabilities of all hypotheses are equal to 1/3. All the conditional probabilities are equal to 1/5. Applying the law of total probability, we obtain the same probability equal to 1/5. So, we have learned a lesson. If we ignore the assumptions required for applying classical probability, we obtain incorrect probabilities. The classical probability formula can be applied only when the sample space is finite and each elementary outcome has the same probability. Thanks for watching. If you enjoyed this video, please give it a like, subscribe, leave a comment, and share it. Thank you, and stay tuned for another interesting video coming soon.